Day 601 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2483, minimum penalty for a shop. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given the customer visit log of a shop represented by a zero index string, customers consisting only of characters N and Y. If the ith character is Y, it means that customers come at the ith hour, whereas N indicates that no customers have come at the ith hour. If the shop closes at the jth hour, meaning 0 is less than or equal to J and J is less than or equal to N, the penalty is calculated as follows. For every hour when the shop is open and no customers come, the penalty is increased. For every hour when the shop is closed and customers come, the penalty is increased by 1. For every hour when the shop is open and no customers come, the penalty increases by 1. For every hour when the shop is closed and customers do come, the penalty increases by 1 as well. Return the earliest hour at which the shop must be closed to incur a minimum penalty. Note that if a shop closes at the jth hours, it means the shop is closed at the hour J. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input customers equals the string YYNY, the output is 2. So it says, if we closing, remember, we want to return the earliest hour at which the shop must be closed to incur a minimum penalty, which means we want the smallest penalty possible. So it says if we close the shop at the 0 hour occurs, then the penalties are 1 plus 1 plus 0 plus 1, which equals 3. So remember up here it says if the character is Y, it means the customers come at the ith hour. Whereas if N indicates that no customers come at the ith hour. So that means customers are coming here, no customer here, but we do have a customer coming here. But for penalties, it says for every hour when the shop is open and no customers close, then the penalty increases by 1. And for every hour when the shop is closed and customers come, then the penalty is increased by 1. So let's look at these explanations to see what they mean by that. So closing the shop at that 0th hour occurs is 1 plus 1 plus 0 plus 1, which equals 3. So if we close the shop right here, that means we have a customer coming here, we have a customer coming here, and we have a customer coming here. It says right here, for every hour when the shop is closed and customers come, the penalty is increased by 1. So since the shop is closed and we have 3 customers that were supposed to come, but the shop closed right when the first customer was supposed to come, that's 3 penalties that we incurred, right? Boom. So now let's see if we could reduce those penalties. So if we close the shop at the first hour, then it'd be 0 plus 1 plus 0 plus 1. So if we close the shop at this hour, then a customer comes here, but the shop is open, so we don't receive any penalties, right? But we do receive a penalty here because now the shop is closed, right? But then the shop is closed and right here, no customers are coming anyway, so it's no penalty. But a customer comes here, so that'd be another penalty. Thus, that'd be 2 penalties if we close right here, 1 penalty from right here, and the other penalty from right here. Then it says if we close the shop at the 2nd hour, incurs and 0 plus 0 plus 0 plus 1, so 1 penalty, right? So if we close the shop right here, then these customers will be able to come, so there's no penalty. We didn't have a penalty, we didn't have customers coming here anyway, so there's no penalty here, but we'll catch a penalty here because a customer was supposed to come, but it was closed. Thus, we get 1 penalty. Then if we close the shop at the 3rd hour, then we get 0 plus 0 plus 1 plus 1. So, which would be 2 penalties. So if we close the shop here, that means we won't get any 2 penalties from this, but if the shop was open and no customers came, that's a penalty. Boom. Right? Oh, sorry, right here. Boom. The shop was open, but we didn't have any customers. So that's a penalty. And then here the shop would be closed, so that's another penalty, and that'd be 2 penalties. Then it says closing the shop at the 4th hour occurs a 0, 0, 1 plus 0, which equals 1 penalty. So, well, sorry. So the 3rd hour would be this. This would be the 4th hour right here. Boom. So if once again, the 4th hour, it'd be no penalties for these because it's open. We get a penalty from here because it's closed, and then we get a no, and then we do get no penalty here because the shop closed after this customer was able to come. So closing the shop at the 2nd or 4th hour gives a minimal penalty since 2 is earlier. The optimal closing time is 2. So we could close the shop right here in the 2nd hour. Or sorry, so we're returning this because it's the 2nd hour, right? But since second right here, we'd have a penalty of 1, which is a minimal penalty, and right here we'd have a penalty of 1, which is a minimum penalty, right? But since this one occurs sooner, that's why we return 2, because we closed in the 2nd hour and it was closer. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our customers equals an array of strings n, 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 n. The output is 0. It says it is best to close the shop at the 0th hour as no customers arrive. So in the 0th hour, we're not getting any customers anyway, right? And we want the earliest hour that we can close at. And since we're not getting any customers anyway, we might as well just close shop for the whole day. Boom. Then it says in example 3, let's take a look at example 3. It says our input customers equals an array of strings y, 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 and y. This time the output is 4. It says it is the best to close the shop at the 4th hour as customers arrive each hour. So in this case, we're having customers come all day. So why would we just rack up penalties and get a penalty for each customer when we could just close at the end of the day and make room for our customers? And that's why the output is 4. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we're going to do is we need to store the best closing hour that we found so far. So we're going to declare a variable. Sorry, y'all. Come right here. We're going to declare a variable. Open up the parentheses. Say j, comma, penalty. So it's going to be a tuple penalty. Sorry, y'all. Penalty. And we are going to set that equal to a tuple of 0, 0 just to start. So J will store the the best closing hour that we found so far, and penalty is going to track the current penalty score for a given closing time. Now, initially, or we need a penalty assuming the shop closes at hour 0, and every Y customer would be missed, so each Y adds a penalty. So to handle that or to check for that, we could come right here. We could say for CN customers. Sorry, y'all, customers. We're going to open up the brackets, and if C equals, open up the quotation marks, Y, then we'll come outside of that, and we're going to open up the brackets, and we're going to say penalty plus equals 1, just like that. Now we need to track the minimum penalty that we've seen so far. So we're going to come underneath that, and we're going to say var min penalty. We're going to set that equal to penalty. Boom, just like that. Now we need to iterate through each hour considering closing after hour I. So we'll say for, open up the parentheses, I, comma, C. Come outside of that, n customers dot enumerated. Sorry, y'all. Put the parentheses, open up the brackets, and if the customer comes at hour I is Y, then moving the closest time past this hour avoids a missed customer, so the penalty decreases. So we'll say if C equals parentheses Y, we can come outside of that, open up the brackets, and we could decrement penalty by saying minus equals 1. Then if a customer at hour I is N, then staying open during this hour adds an unnecessary open penalty. So to check for that, we'll say if C equals, open up the quotation marks, N, then we'll come outside of that, open up the brackets, and say penalty plus equals 1. Now, if the current penalty is lower than any seen before, we're going to update the best closing time to I plus 1. So we'll come underneath this and we'll say if penalty is less than min penalty, we'll open up the brackets, open up the parentheses and say j comma min penalty. Come outside of that and we'll say equals, open up the parentheses, I plus 1 comma penalty. Boom. Then we're going to come underneath this and we need to return the earliest hour with the minimum penalty by coming right here, and we could just say return J. Should be all she wrote, y'all. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. Let's see, and look at that, y'all. 30 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.